Welcome back, everybody. Thank you for tuning into my channel again, and so sorry I haven't posted for the last few weeks. I had final exams and I didn't have time to post any content. So today we'll be branching out into a new subject that's not math, science, more specifically chemistry, and more specifically atoms, isotopes, and ions. A comprehensive exploration of atomic structure, mass units, and the electrical dynamics of chemical reactions. Module 1. Atomic structure, the foundation of all matter in the universe. Subatomic anatomy, the balance core. The atom consists of a dense nucleus containing a proton, which is positive, and a neutron, which is neutral, surrounded by the electron cloud, which is negative. The electrostatic attraction between the positive nucleus and the negative electrons keeps the atom together. Particle properties. So, the particles you will find in an atom are the protons, the neutrons, and the electrons. So, the charge for a proton is +1 or positive. Its relative mass is 1 AMU. AMU. You might be asking, what is an AMU? An AMU is an atomic mass unit, which basically is the mass, which is usually the measuring unit we use to measure really small particles and subatomic particles. So its role is to define element identity. The neutron has no charge, as you can tell by the name, and has the same 1 atomic unit mass. And its role is provides nuclear stability. Electrons have a negative charge and have a really small mass compared to the others, only 0.005 AMU. And the role of the electron is to govern chemical bonding. Basic atomic math. So, mass number versus AMU. While the atomic number is the proton count, the mass is the total number of protons and neutrons. So the mass number is equal to protons plus neutrons. For example, we have the atomic number Z, which is 6, and obviously that's carbon, and carbon will have usually 6 protons and 6 neutrons, but we'll get more to that in a few slides. Isotopes and atomic mass. Isotope variations. Isotopes are atoms of same element that contain different numbers of neutrons, resulting in different masses. Identical chemistry, because they have the same electron contribution. Isotopes that behave identically in chemical reactions. Isotopes of carbon. The most elements exist as a mixture of isotopes. For carbon, 2 main stable isotopes exist in nature. Carbon-12, the one I was just discussing about earlier. 6 protons, 6 neutrons, and has a 98.9% abundance. Carbon-13 has 6 protons and 7 electrons, with 1.1% abundance. There are also traces of radioactive isotopes like carbon-14 used in scientific data. Calculating the average atomic mass. So here's all the information you need on carbon, on the left. And the weighted average AMU is the mass of the periodic table. The mass of the periodic table is weighted average of all natural isotopes based on their relative abundance. For example, we can use carbon. Average mass of there's 2 main types we use that. Carbon-12 is 12 multiplied by its abundance, so its atomic number. Its mass multiplied by its abundance plus your other atomic mass multiplied by its abundance, and so on and so forth, depending on how many major isotopes there are. In this case, AMU of carbon is 12.011, not 12 exactly. Dynamics of ions, module 3. Cations versus anions. Cations is formed when an atom loses electrons. The positive protons now outnumber the negative electrons. For example, sodium is Na+. An anion, which is negative, formed when an atom gains electrons. Negative electrons that outnumber positive protons. For example, Cl which is chlorine, becomes Cl minus, chloride. So basically, how to relate, we can say cat from caption, and say, you know how cats have paws, right? Well, you can match it with positive. And with anion, you have an. An in most circumstances mean opposite. So you're taking the opposite of positive. Still, that'll be negative. That's how you can remember that. Summary and conclusion. In summary, matter is defined by the proton, weighed by the neutron, and energized by the electron. Understanding these shifts allows us to calculate weighted atomic masses and predict chemical reactivity. Atoms, neutral building blocks where protons equal electrons. The atomic number Z defines the element. Isotopes, atoms with different neutron counts. They change the mass AMU but keep chemical properties the same. Ions, charged particles formed by electron transfer. Cations lose electrons and anions gain them. And that's it. Thank you guys for watching, and hope to see you in the next math, science video, or any other subject video that comes up next. Thank you for listening.